Alright, so you've decided you need to upgrade your gaming computer to be more performant in either Unity or some other game engine to make video games, but you're not exactly sure what you need to upgrade, so I decided I would do a little chart here to help people decide what they need to upgrade if they're going to be making video games. You'll be surprised, it's actually a little bit different than playing video games. So first off, this list is going to be in order from what I believe is most important to what I believe is least important. That doesn't mean the most important thing on this list is what you need to upgrade. It just means you need to look at your system, see what's in there, and make the smart decision for yourself what you need to upgrade. Okay, so first things first, most people would probably think if you're developing a video game, you need to upgrade your GPU. After all, it's a video game and you want to get better graphics, right? The downside there is you probably don't need to upgrade your GPU. If it's anything better than like a RX 550 or like a GTX, maybe 1060 or 1080. Reason for that being is unless you're targeting extremely high graphics in the game you're making and you're trying to use Unreal Engine, this can be number 2. And our processor can be number 1. And the reason for the processor being number 1 is it's way more important in terms of getting your game engine to perform rather than, say, getting more graphics out of your game, because what you need when you're making a game is workflow, not necessarily good graphics. And the other reason you want a CPU, or what am I doing there? The other reason you want a CPU over a graphics card, or a good CPU rather, over a good graphics card when making a game is the CPU is going to be responsible for handling the compilation of your code. So if I were to open a script here, making a change to your script and saving it compiles it. Of course, in Unreal Engine, you would have to save the script and then recompile the engine. But you see the loading bar, private, let's just make a variable, see if it takes any extra time, private float. This loading bar pops up, and that's how fast it takes to compile code on this i7 13th generation I'm using. Even if I'm working on like a really big project like the zombie game I'm currently working on, and I make a change, compilation speed just takes a few seconds, and it's done like that. As to where with like a slower processor, like an i5, or like the old Ryzen processor I had, sometimes I would wait as much as like 10 or 20 seconds for the same thing. So again, to recap, the CPU is more important because it's going to help with the performance of your engine, and as well as it's going to increase the compilation speeds of pretty much any game engine you use when you're compiling code. All right, so moving on, the next most important thing, I would say even still more important than your graphics card, would be your RAM. And this is because, first off, game engines use quite a bit of RAM, and depending on what you're doing in the game, you're going to be using more and more of that puppy. And let's say you want to have like extra applications open like Photoshop and maybe even like a video editor because you're making a trailer for the game and all that, you're going to need to have a good bit of RAM. So I would recommend at least 32 gigs for making video games. You could probably get away, since people sometimes think you have to do it in rounds of 4 or 8. You don't. I would say at least, actually more like 20 to 24 gigs. So if you're at that limit, consider thinking more. Another reason you want more RAM is if you want to run more monitors. I have 3 monitors running. It takes a considerable amount of RAM to keep every monitor loaded with stuff on the screen. So I have 64 gigs of RAM, which is more than I need, but that's why I have it. All right, and moving on from there, I would also probably once again gonna have to move down the graphics card even 4 here. I know this is gonna piss a lot of people off because these are video games and graphics are very important in video games, but again, this is about making video games, not about playing video games. And the reason I have to put this above the graphics card once again is because if you're using a regular solid state drive or an M.2 on your main OS, that is like your C drive, like your C drive like that. The reason you want a M.2 drive to have your main OS is because M.2s are the fastest. I think they're the fastest. There's like one other kind of solid state drive, if anyone wants to remind me and fill me in. I forget what it's called. But I think M.2s are the fastest to have your OS on. If you have your OS on a regular solid state drive, you're probably not going to really notice much of a difference by upgrading to M.2. I sure as hell didn't, but apparently it is definitely faster if you have the mind of a ninja, you could tell. So that's the reason I'm going to put that above the graphics card, but then below the graphics card, I'm actually going to put regular solid state drives because they're useful, but I wouldn't say they're more useful than the M.2 drive, because you want the fastest possible drive on your main OS, as I said. Or maybe we could even like tie this with the graphics card. 3, 4, and 5 are basically all tied if you want to. They're all very important at this point. I would just argue still that the CPU and RAM become your most important things when using game engines. So moving on to regular solid state drives. Regular solid state drives are good for main OS or backup drives and project drives, because you can even have your games on a regular SSD and then have like your OS on your M.2 like I do. So all my projects are on regular SSDs, and then everything on my OS is stored on my M.2, and I just have like, I think honestly 3 or 4 maybe extra SSDs in there that are like 2 terabytes each, and so that's enough. That's a lot of space. And then of course number 5 is a hard drive. I'm not going to say this thing is completely useless, but I wouldn't put projects or anything on a regular hard drive these days, and I would keep it for backups only. And that's honestly only if you have a hard drive still and you're just determined to use its space to save your solid state drive space. Then yeah, use it for try to just keep backups on your hard drives rather than loading them from your solid state drive, because then your projects are going to go very slow, and no matter all of this stuff we just talked about is going to be useless if your projects or your OS is on a hard drive. So hard drives, throw them away if you can. If you can afford it, replace them with solid state drives. Much faster. Even backing stuff up will be faster because they read and write faster. So yeah, I replaced everything because I do all my backups manually, both on cloud and on regular hard drives. So I decided I would get all solid state drives, because once you're copying 50 gigs at a time, it takes a while, and you don't want to wait a half hour to an hour for 50 gigabytes to copy every single day. So yeah, that's basically my video on what you should upgrade for your computer if you're making games and not just playing them in that order. See you guys next time.
Thanks for watching this video, guys. If you liked it, hit the like button. If you disliked it, hit the dislike button. Please subscribe and hit the bell icon so you don't miss any more future videos.